Okay, today's lesson is about exponents. We're going to be reviewing what you already know from last year, and I'm going to show you my own shortcuts for how to simplify expressions that have exponents. First, let's go over the regular rules. And since I don't see you, you can't raise your hand or something, just interrupt by unmuting your mic and saying, I have a question. And then I will pause and I'll help you out. So let's first talk about negative exponents. When I think of negative exponents, I think of one word, and that's fractions. Now, as you know, since I'm recording this, you can either take notes right now, or you can rewatch the video and take the notes later. Okay, let me do an example of a negative exponent. Let's say I have 2 to the negative third power, and I say evaluate. Evaluate means to give me the value of this. Well, to make a negative exponent positive, I change its level. And if I were to think of this as a fraction like this, I can see the negative 3 is in the numerator. To make it a positive exponent, it's going to go down to the denominator. Then I evaluate 2 to the third power, and I get 8. Another example. What if I have a negative exponent on the bottom? Well, to make a negative exponent positive, I change its level. So it's going to go up to the top. There's nothing left on the bottom, so I'll put a 1. This answer will be 9. If you were to try out 3 to the power of negative 2 on your calculator, what would you get? Well, we've got to write it the normal way, which is 3 to the negative 2. And that has the invisible 1 underneath. Now I have a negative exponent. To bring it down, I need to make the exponent positive, and that gives me 1/9. Okay, let me give one for you guys to try. I want you to simplify this for me. 4 to the negative 2 times 5 to the third. 4 to the negative 2 times 5 to the third. Give me this as a simplified fraction. Okay, I want to make this negative exponent positive, so it's going to go down to the denominator. Then I do 5 to the third, do it in my calculator, 125, and 4 squared, which is 16. 125 and 16 do not reduce. This is a simplified fraction. Done. Let's continue. Zero exponent. Any number to the 0th power equals 1, except for 0 to the 0th. Any number to the 0th power equals 1. Any fraction to the 0th power equals 1. Negative numbers to the 0th power equals 1. Decimals to the 0th power equals 1. And pi to the 0th power equals 1. Whoa, why did I write a 0? 1. Any questions? If you have a question, go ahead and speak up now. Product rule. The product rule is when you're multiplying the same bases with different exponents. What if I had, for example, 4 to the second times 4 to the fifth? We always seem to forget. What do we do with the 2 and the 5? Do we multiply them or add them? Here's what I want you to visualize. 4 to the second is 4 times 4. 4 to the fifth is 4 times 4 times 4 times 4 times 4. I can see this is all just multiplication. And when I put it all together, it'll be 4 to the 7th power. That means the product rule is adding. You add the exponents. Let's try one. What's 2 to the 8th times 2 to the negative second times 2 to the negative 6th? Go ahead and simplify that for me. I'll give you 10 seconds. Okay, since these bases are all the same, I can add the exponents. Be careful, because if the bases are not the same, you can't apply the product rule. So I'm going to get 2 to the 8 minus 2 minus 6. 8 minus 2 minus 6 is 0. Oh, 2 to the 0th power is 1. Wait a second. Let's do a sidebar here. Let me take off this paper, and let's analyze this a different way just to see if it really works. Here's the problem once again. I had 2 to the 8th times 2 to the negative second times 2 to the negative 6th. What Mr. Gonzalez said was negative exponents have to change from numerator to denominator to become positive. I can rewrite this as 2 to the 8th over 2 to the second times 2 to the 6th. The two negative exponents go down here. Let's apply the product rule. And the product rule says if you have the same base, you can add the exponents. 2 plus 6 is 8. And what happens when you have the same number on top and bottom? They reduce, and it equals 1. If you remember a moment ago, that's exactly the answer we had. 2 to the 0th power equals 1. It's the same. Any questions? Okay, the quotient rule. If the product rule is adding, the quotient rule is subtracting. 2 to the 12th over 2 to the 10th. These are the same bases. That means I can subtract. My answer is 2 squared, which is 4. You can try this on your calculator. You can go 2 to the 12th divided by 2 to the 10th, and you're going to get 4. So what about when you have a negative? 3 to the 5th over 3 to the negative second. Well, using the quotient rule, they're the same base, so we're going to get 5 minus negative 2. Minus a negative means add. 5 plus 2 equals 7. Looks good. Let's see if we can get this a different way. Negative exponents change levels to become positive. That means I can put the 3 to the second on top. We have the invisible 1 down below. Now we have the product rule. 5 plus 2 equals 7. And we get the same answer once again. Multiple ways to do the same problem. Now, I apologize in advance if you have been the type of person to say, no, just show me one way and that's it. You're confusing me. We're going to look for different approaches and different ways to do these problems. eventually to become more efficient and do it the fastest way. When grandma is taking you to go somewhere and grandma says, "No, I can't go on the freeway. I only like city streets. They're slower and I understand them, but it takes an hour to go somewhere that should have taken only 10 minutes." You can see that sometimes it's appropriate to take city streets, sometimes it's appropriate to take the freeway. We have to learn all different ways because there can also be roadblocks. That's our goal. Learn as many different ways to do problems, not as many different ways, but several different ways to do problems so that we can use the best one for the best situation. Any questions at this point? Let's continue. Parentheses. First off, if you've got a power to a power, like 4 squared to the 5th, well, we know the 5th power means write it out 5 times. But we have the same base here. We can now apply the product rule. I can add 2 5 times. That equals 4 to the 10th. So hey, it looks like when we raise a power to a power, we can multiply the powers. Second thing with parentheses, we distribute powers. I'm going to start right off with a difficult one. 2 to the 3rd over 5 squared and 7 to the negative 1. And I'm going to raise this whole thing to the negative 3rd power. All set? First, I want to look inside the parentheses and see if there's something I can simplify. You don't have to do it this way. You can do the next step first and then you can go in either order. This is what I do. I see the 7 to the negative first. I want to take it upstairs to make it positive. So I'm going to rewrite my problem like this. Now here's the other rule that you do with parentheses. I'm going to distribute this exponent to all the other exponents and multiply. That will give me 2 to the negative 9th, because 3 times negative 3. It will give me 7 to the negative 3rd, and it'll give me 5 to the negative 6. These are all negative exponents, which means we need to change their levels to make them positive. Take the 5 to the negative 6th up top, make it positive. And on the bottom, we'll have 2 to the 9th, 7 to the 3rd. I'm just going to circle this because I don't have my calculator right now. But I can see that since these are prime numbers, nothing will cancel, and I can just do this on my calculator now. Okay? Do we have any questions so far? Okay. Let's continue on. Those were with numbers. We're now going to do it with variables. What does it mean to simplify an exponential expression? We want no more parentheses. We want no powers to powers. Each base happens only once. And there's no negative or zero exponents. This information is in the text that I attached to your homework. It's also in your Blitzer book for periods 1 and 4. I'm going to show you how to simplify a few expressions, and then we're going to try some out on the homework. Here's my first example. Let me put a box around this so you don't think it's a fraction. Okay, parentheses, expression to the 3rd power. I have to distribute this 3 to each item here. Watch what I do right here. Be careful. -3 has an exponent. That exponent is 1. We're going to do -3 to the third power, and you need to put that in parentheses. Okay? Because if this were a 2, we need to put the whole thing to the second power, and it's going to become positive. Here, x to the 4th to the 3rd means x to the 12th. Y to the 5th to the 3rd distributes the 3. Y to the 15th. And now you do -3 to the 3rd in your head or on your calculator. -3 times -3 is 9. Times -3 is -27. X to the 12th, y to the 15th. When you do problems and turn them into me, it's best to circle or box your answer. That way I can see it quickly. Any questions? Let's continue with the next one. I have two expressions here. Neither parentheses has an exponent on top. So I can basically take the exponents off or imagine it without. So what I can do here now is multiply my numbers first. -7 times -2, that's 14. Now I'm going to underline the x's and know that I have to combine them using the product rule. Let's add the two exponents. This has an invisible 1 up here. Be careful. 1 plus 5 is 6. And then we just do the 4 and the 6. I'll do a double underline to know that I've used it up. 4 plus 6 is 10. Circle or box your answer. Now, if you think I'm going fast on these are all available as well in your textbook. They may even do a different approach. And if you need me to redo it for you, we can do it again later after this video. Next example is a division one. It's very similar to the last one because there's no parentheses with an exponent that you have to distribute. So here's what I do with these ones right here. I first do the numbers. In fact, I like to rewrite it like this. And then I put the others over here. Okay, so I say, okay, -35 and 5, what goes into both of those? 5 does. 5 goes into there once. 5 goes into there, let's say -7. I bring the negative up there. So here's what I have so far. -7 over 1. Now, if we use our quotient rule, when you have the same bases, you subtract. 2 take away 6. 2 take away 6. And here, 4 take away -8. Notice that I am putting the answers on the top line. When you directly apply the quotient rule, you put your answers in the numerator. Let's continue to simplify. I get -7 x to the -4th because 2 minus 6. And 4 minus -8 is 12. Do I have any negative exponents here? Not negative numbers. We do. Leave this -7 on top. X to the -4th goes to the bottom, the denominator, and y to the 12th stays in the numerator. I'm done. Anybody have a question on that? Now for some real learning right here. I'm going to do Mr. Gonzalez's quotient rule, which is much faster. Let's get a little space here and rewrite the problem. And see if you can follow me. The numbers are done exactly the same, -7. But here's how I approach the variables. X squared, x to the 6th. Which number is bigger? Well, the bigger number is x to the 6th, so my final answer will go wherever x to the 6th is. It'll go on the bottom. Now let's subtract them and get a positive answer. What is 6 take away 2? 6 take away 2 is 4. Let's go to the y's. What is a larger number, 4 or -8? Positives are always bigger. Let's put the answer where the y to the 4th is and subtract. 4 take away -8. Be careful with the double negative. 4 take away a negative means to add, and we get 12. I'm done. Look at my work. Look at the traditional work. You can choose whichever way you like, and if you need another example using my method, I'd be happy to tell you. Let's do our last example here, and I'm going to do it the traditional way and then Mr. Gonzalez's way. The traditional way says to distribute the exponent to all the other exponents. And I can see the 4 has a 1 invisible there and the y has an invisible 1 there. So when I distribute this, I need to distribute it to the 4, the x, 2 times -3, and the y. Now we just start applying our rules. Negative exponents change levels to become positive. The 4 to the -3 goes to the denominator to become a positive. The x to the -6 goes to the bottom to become a positive. And the y to the 3rd goes to the top. I'm done if you remember the rules of simplifying. I don't actually have to find 4 to the 3rd. It's easy to do, but in this moment, I don't have to do it. Okay? If we were to put the answer on Go Formative, it would be much easier to put the actual number of whatever 4 to the 3rd is instead of 4 with the caret and the 3. Now, one more way to do the problem, my way. When I have a negative exponent outside of a parentheses, to me that just means take the reciprocal, like it meant fraction before. So the first thing I'm going to do is just flip them. And now that exponent became positive. Now I can distribute a positive number to all of these. I get y to the 3rd, I get 4 to the 3rd, and I get x to the 6th. If that's easier for you, go for it. If you prefer the other method up here, feel free to do that. Do we have any questions? Okay, I will pause the recording now.